Thank you for purchasing Falmouth Scientific's two-dimensional acoustic current meter, or 2D ACM. This is a short video quick start guide that will help familiarize you with the instrument. We would also suggest that you read through the manual that was included with the instrument prior to deployment. In this image from the technical manual, you will see a picture of a shallow version of the 2D ACM in the 1.5 ton frame. Here you can see the acoustic transducers, the bulkhead connector where your communications cable would connect, the location of the temperature sensors, the zinc anodes, the main instrument housing, and of course the frame. Here's that same instrument depicted in a 5-ton mooring frame, which is an option. In this image from the manual, it shows two other configurations of that same instrument. On the left you will see the deep water version, titanium version of the instrument with a CTD module on it in a 5-ton frame. And on the right you will see the shallow version, or 200-meter version of the 2D ACM in a 1.5-ton frame with the CTD module, the shallow version of the CTD module installed. Prior to configuring your instrument, you need to connect it using the included test cable to your serial port on your computer. In this image or this page from the manual, it shows how to connect it up to your serial port. And in this image, it shows if it's an RS-485 configured instrument, how you would connect the RS-485 to RS-232 converter in order to communicate between the instrument and your computer serial port. And it's very important to make sure that the kickstart switch, which is in the test cable, is set to on prior to trying to communicate with the instrument. Now we're going to go through the ACM Pro software, which was included with the instrument, and show a simple, typical configuration of the instrument. So this is the opening window of ACM Pro. The first thing you always do when you connect an instrument up is to click on Configure and check Instrument, and the software will go out and query the instrument and populate this window up here with the model number, serial number, the version of firmware that's included in the installed in the instrument, and the last calibration date. So now we want to configure the instrument by clicking on Configure, Configure Instrument. The software again goes out, queries the instrument to look at all the different parameters that are currently in it. This is the Configure ACM window. For this particular deployment, we're only interested in north and east velocities, and this instrument also has a CTD module on it, so we will click that off as well. The XY velocities and path velocities are raw measurements that are used in the calculation of the north and east velocities, so we don't need to log those. Again, what we're doing is selecting the channels that will be logged to the internal memory. We're not checking off sea temperature or sound velocity because those will be calculated by the CTD module. If you do not have a CTD module, you may want to select sound velocity and sea temperature, and also battery voltage if you wish. The user A to D channel 1 and 2 are reserved for if you have external water quality sensors or other types of external sensors connected to this instrument, which are available as options. The next tab is for configuring the compass. This simple deployment will use tilt in the X and Y axes and direction 0 to 360 degrees from the compass. The X, Y, and Z compass readings are used in the determination of direction, but we're not going to log those to memory to save our memory. For this application, we are going to check off use the compass and use the tilt in the velocity calculations. There may be applications where you don't want to do that, but for this application we will be using those. This is where you would select averaging if you wanted to get average north and east velocities or average tilt, and where you would put the average interval in. For this application, we're just interested in instantaneous readings, so we're not checking this off. These parameters are explained in more detail in the technical user manual. Under time, the time tab, this is where you would put in an interval and your on time. If you wanted to record at an interval, say every 6 minutes. This is configured for every 6 minutes. So every 6 minutes it will come on and record for 30 seconds and then shut off for another 6 minutes. The other things you can set here in this window is if you wanted to configure the unit to start at some delayed time and date, you can put that in here as well, so you can configure the instrument at your desk and then take it out in the field and deploy it, and it will start automatically. Here is what the internal time and date are reading currently from the instrument clock. If you click on set, it will synchronize with your computer clock. Here is where you would select record time in memory. For this application, we want to record the time so we can correlate the measurements to certain times. There may be instances where you don't need to do that. Under memory, this is where it reports how many bytes each record will represent based on what those previous configuration selections that you made. This is also where you will select log data to memory. It's very important if you're going to log data to the internal memory to check this off. It does not get checked as a default. So you need to check that every time you deploy the instrument. There are applications where you don't care about logging data to the internal memory, where you would be streaming data up through the RS-232 or RS-485 serial communications. But for this application, we want to log data to memory. The Statistics tab is basically an onboard calculator where it says method of deployment. When you select delayed, interval, or continuous, you're not selecting how the instrument is being deployed at this time. You're just seeing how your memory fill time and your battery life is affected by choosing one of these deployment methods. You will select the method of deployment when you actually deploy the instrument. So this is just an onboard calculator, if you will. And the options tab is if you wanted to have this instrument connected full time and get real-time data, you would click on that and it would stream data out through the RS-232 port. So now that your configuration is done, you click on save. It does a /E, which is a terminal command that saves that configuration to the memory of the instrument. So now we want to deploy the instrument. So we would say run instrument, deploy. Basically what happens is every time the instrument is deployed, it records one data file in the internal memory. So in order to launch it, we need to erase the original or what was in the memory previously. So it's always important to offload any valuable data from your instrument before you redeploy it. So here we say yes. It goes out and it does the terminal commands to the instrument to clear the memory and reset the logging pointer to the beginning of the memory. So now we're ready to deploy the instrument, and this is where you would select if you want continuous, interval, or delayed mode of deployment. For this short deployment, we're going to click on continuous so we can actually see some data in a very short period of time. Again, the data will not be very meaningful because the instrument is in air. It's not deployed. It's just in my office. But for the purpose of this exercise, we will select continuous. So we click OK. This is an interesting feature of the software. It creates a deployment summary screen which tells you the date, the time, the record size, basically all the information that you saw from those previous windows. How you configured the instrument, the measurements that you selected, the runtime, the sample rate, etc. You have the ability to print this at this point and save that information. I find that it might be useful for future reference when you're looking at historical data to have a paper copy of exactly how the instrument was deployed. So I think this is a nice feature and something that you may want to use. So here we click on deploy, and the instrument will deploy and begin recording. It says run continuous mode. The ACM instrument is now running in continuous, and it tells you to remove the test cable and replace it with a dummy plug and deploy the instrument in the water.